Hello and welcome to Roid Rage episode 64. My name is Jack Byer and I'm head of media here at AstroForge. Joining me today we have Matt, our CEO.
What do you want me to say? You always do this. Like, yes, hi, Jack. Same conversation as always. Just continue, read the fucking prompt.
And we have Nathan, our flight software manager. Today we're going to talk about something that is one of the most mission critical things on the spacecraft, which is of course the power management software. It doesn't matter how efficient your thrusters are, or how good your comms are, or how badass your payload is. If the software that decides when and what gets power messes up, you're probably going to have a bad day. So Nathan is the exact right person to talk about this, which is why we have him on. And we're going to forego the news today and just get right into it. Does that sound good to both of you?
Sounds good.
I'm kind of sad about that, but
Is there any news items you that are just burning in your mind that you really want to talk about?
Aether Flux.
dude, someone changed their name to Cowboy fucking Space, and you
Do
left
we really
that
have,
out.
we really have to talk about that?
It's amazing. What are you talking about? It's probably one of like the best. Like their logo is a big giant piece of steak with the logo on branded onto it. Like
But their
media
sizzle
team,
reel.
they had a sizzle reel. You know why? Because they're barbecuing. You know why? Because they're cowboys. Like the media levels here is just exceptional with them. I just got to give a big shout out to the greatness that was the branding of Cowboy Space.
What were they before? They were Aether something?
Aether Flux.
Aether Flux.
Yeah.
I will withhold my opinions.
Kind of a cool pivot, though.
It's kind of a cool name too. It's a
Cowboy
cool
Space.
pivot.
Cowboy Space is an okay name. Do I believe for a second they'll succeed? Personally, absolutely not.
Ooh, hot take.
Whoa. I think look, I think what they did was they looked at a rocket and they said, "Hold on. For instance, we've always decoupled the rocket from the payload.
For good reason.
What happens if you don't do that? Well, what is the good reason, right? You have a fairing that has to depart. That's extra mass. You have to have a thruster on there. That's extra mass. Like you can't use it for repositioning or anything. The mass fraction on a second stage is 1-to-1. So every extra pound you have is an extra pound you're not putting on a spacecraft vehicle. You actually get a lot of savings by combining those together. The fairing now can be made to be a deployment mechanism or in a different shape. I mean, to be fair, Starship has actually started to think about this. Like the fairing is extra mass. What if they don't have it? That's why you have the Pez dispenser on Starship. This is like the next iteration of just saying, what if we built the whole thing? It is no longer a general purpose launch vehicle. It is a bespoke launch vehicle meant to launch one product. And at that, whether or not you believe that that product will be successful, like data centers in space, verdict is still out. We can all have our different opinions on whether or not that's true. This is probably the most mathematically efficient way to get data centers to space per kilogram. And so you got to give them credit for at least re-underwriting how they thought about going to low Earth orbit.
I do like new ideas and creative solutions to problems. I will have to see more than a fancy sizzle reel to
Nathan,
buy
you're
into
right.
the hype.
You're right. Jack is just in a bad mood today.
Yeah, it's unfortunate.
I'm
but,
always in a bad mood.
He's kind of being a little emo.
You gotta have.
How is your
those
Land
days.
Rover doing? Did you buy the new one?
I did buy the new one.
You did.
Oh, you did.
Holy shit! How was that not like a Twitter? Like, how did you not write a love letter to the
Where's
former?
the sizzle
I
reel
don't
for
have
the?
the-
Yeah, where's
I don't
the
have the-
sizzle reel for the Land Rover?
I don't have the title yet.
Oh, that's why.
That's what's stopping you.
In part, also, I don't know, like
I mean, you have a
my
roof
very
now.
day-to-day responsibilities.
Back to you.
Like,
That's fair.
there's a lot of things I would like to do creatively in my personal time. Most of the time, it ends up being like laundry, walk dog, sleep,
You watch those
clean
clothes?
house. Yeah, actually, last night, which is why I'm in not a great mood, is because okay, here we go, inside baseball. The fucking laundry machines in my apartment complex used to be coin op. I've been there for like 14 years. Like 7 years ago, they changed it to a stupid card situation where you have to insert a card into a machine, put dollars in the machine, and then it loads the card. You cannot use ones for some reason. So you have to have either 5, 10s, or 20s. That machine's been broken for 3 weeks. So I have been unable to do laundry for 3 weeks. And I was like, oh, I'll wear this shirt I hate. I'll wear these pants I hate. I've been doing that for 3 weeks. And finally, last night I hit up management and was like, yo, give me a card. Like I need a laundry card to be able to do this. So they gave me one and the laundry room was occupied. And so I ended up finishing laundry at like, I don't know, 2, 3 last night. Just furious with myself for even trying. Like I should have just done like a shirt and a pair of pants and been done. But hey,
AM?
huh?
2-3 AM?
Yeah, I'm exhausted.
Whoa. Okay, so now we understand.
You know, There is this crazy concept. I mean, I know Cowboy Space, like they put a lot of engineering into it. You probably don't have to put this level. You could just move.
I could move.
Laundry mats too.
Yeah, laundromats. There's other
Laundromats
ways.
also exist. I could do what my mom keeps saying to do and just have a laundry service do my laundry. I'm sure there's creative solutions to this problem. Maybe I should contact Cowboy Space for some creative solutions. The laundry machine
do worse than
is
you
my
did.
closet. Problem solved.
Can we
You did this. You started it. All right, let's get into it. For starters, when we say power management software, what are we actually talking about, Nathan? Because I think a lot of people probably imagine like a fancy fuse box or something. I mean, I imagine a fancy fuse box. Matt's rolling his eyes, but it's a fancy fuse box, right?
At times it can be, yeah, definitely.
But no, like the management software specifically, though, what does it do? And don't say it manages power, or otherwise I'm going to throw my laptop at you.
So there's kind of two parts. Like there's power gen, and then there's turning stuff on and off. And so what we do is we create something that automatically generates power based on the current system demand, and then we have a nice infrastructure for turning stuff on and off. And so this can be from the ground operators, or this could be from autonomous sequencing on the spacecraft. So you create a nice framework where you can just say, I want to turn this component on, I want to turn this component off. And you can build higher level logic on top of that, like thermal control loops and other spacecraft modes.
Nice.
Hold
So
on. So you have power gen. Does that? You made it sound like we invented some new way to make power.
Not really.
Like, can we take a little bit of
Yeah.
step back? What is the point of power management software? Like, why even have it? What are we trying to do?
Sure. We have a finite amount of power on the spacecraft at any given time. It's dependent upon the irradiance upon the solar panels and the distance, which is also correlated to the distance from sun. So if my panels are kind of canted off, you have some cosine loss there. Or if I'm really far from the sun, say I'm 1.2 AU, I have less irradiance. When I'm closer, I got more irradiance, which is watts per meter squared. So the closer you get, the more general power you have, and it's also dependent upon spacecraft orientation. So based upon that, we can actually kind of modulate the amount of power we pull in from the arrays, and we do that through our power stages. And then you have onboard batteries that kind of hold you through minor eclipses, or if you have issues with solar panel pointing, or during like the separation sequence where there's a non-zero amount of time where you're not fully illuminating the panels.
So at one Earth distance, 1 AU.
Yeah.
I think we have is it 1341 watts per meter squared?
Like 1367.
1367 watts per meter squared.
In space, because it's also like there's no atmosphere, so you have no loss there as well. So that's kind of like the
Sure. In space, we have
Yeah.
1367 watts per meter squared.
Yeah.
We have 6 panels. Each one of them is about a meter squared.
Yep.
Right? So we're getting 1,300 watts per panel of sun energy that's hitting them.
we can do, and this is also temperature dependent as well. So
Sure, but as a general rule, we're getting
Yeah.
about, let's round up, 1,400 watts per panel that is hitting them. And our solar panels are 30%, 33% efficient. Right?
Sure. I don't know the exact numbers on that, but yeah.
So we're getting like 350 watts per panel of power that's coming in.
Yeah, it's about right. I mean, on the max side, you can do up to, let's say, 375, but yeah.
Okay, so let's just say 350.
Yep.
I got a question for you. What happens to the rest of it? It's like the panel absorbed 1,400 watts of power.
Mhm.
We're only transmitting 33% efficient solar panels. What happens to the other 67%?
Is that just heat?
Yeah, Jack's right. He's going to join the team.
I'm doing avionics now.
So it just is heat.
That's my understanding, because right now it's based on our load demand. So if we're flying a thruster at 1 kilowatt operating point actually demands about 1,200 watts. And so based on the system demand, we'll pull out, say, up to 900-ish watts, given this scenario, from each side if we need to. But it usually looks around about 650 watts per side when we're in like a thrust scenario, roughly.
So when you're in max power mode of the spacecraft,
Yeah.
you're taking all of that 350 watts that we get and doing something with it on the spacecraft.
We
and
lose some power across like the power stages itself. There's like converter efficiency, so we use buck converters, so we'll lose that across. There's switching losses as well. We lose that as generally just as heat. So
And then we turn off that solar panel. So when you're deciding not to use it, low power mode, like all of that just becomes heat.
yeah, so we basically modulate ourselves on like this is kind of getting into the weeds of it, but we have solar panels have an IV curve, On the x-axis, it'll be voltage. On the y, it'll be current. And so we kind of basically we set the panel voltage to kind of set how much power we're going to get from the panel. And so if we need, say 315 watts or so, we'll walk our way up to the peak power point, and then that gives us our maximum amount of power. And this also varies with temperature, so we're very efficient throughout the entire operating regime of the spacecraft as well. So,
Sorry, it's 350 watts per panel, and we have 6 of them,
We
right?
have 6 of
Yeah.
them, yeah. But what's really cool to understand about this is that when you don't pull power from a solar panel, it gets hotter. And when you pull power from it, it gets colder. It's like very counterintuitive.
Yeah,
in
that
the way
kinda
you would
hurts my
think about
head.
it, right? Because you're not having to disperse as much radiation out the back of the panel.
but you pull it into the spacecraft body itself. So
Yeah, the power has to go somewhere.
Yeah.
Right. Like no matter what, whatever power our panels catch, we have to do something with it. It has to be radiated out. And the back of the solar panels are a big radiator. They can also get much hotter than the spacecraft.
Yeah.
Intentionally.
that's a much more complicated thermal question that I can't answer.
That's all right. We
but yeah.
did thermals in our last episode.
Perfect.
So
Yeah.
I think we're good to go.
Cool.
Although, is there actually radiator hardware on the back of the panels, or is it just like the surface area allows
No, I
it
mean,
to?
the radiation, the black body radiation is T to the 4th that you go. So the hotter you get, you're going to go at quadratically more radiative power out. And so no, they have an emissivity of them, but they just get hot. They'll just transmit directly from what's hitting that panel through the aluminum honeycomb back to the backside of the carbon out of the spacecraft. That's why they're coated on the back with a very specific material to have a higher or lower emissivity. I forget which way it goes.
So it's like a coating. It's not like a physical hardware
It's
structure.
actually
or
black
anything.
capped on tape. Yeah, that is put on the back of them over the weave of the carbon.
Nice.
So makes it cost a shitload of money. It's like a Bugatti Zonda. Was that how you say it? The
Bugatti?
Pugani? Pugani?
Pagani.
What are you talking about?
Car? He's
The
talking about a car.
Oh, the car.
That car that I can never pronounce.
Don't look at
Pagani?
me, dude.
They do some really cool stuff with carbon weaves.
Do they? Okay.
That's where I was going with this.
Oh, composite works are incredibly complex and can be
They're really not.
really.
No,
Okay,
they're not.
cool.
It's just a whole bunch of dudes that go in there and they're like, dude, if we weave carbon fiber and aluminum and titanium together, we can make up a new name. And they do it and they're like, oh, look at the weave. Like, it's extremely complex, but I'm going to say it's not.
When are we gonna get an automated fiber placement machine?
Probably never.
Yeah, I don't think we would actually have a need for one, but I want one. They look cool. They're fun to film.
Jack, you just bought a car that's drivable.
Are you saying my old one wasn't drivable?
Yes.
It demonstrably was. I drove here every day. It just didn't look good. Didn't look drivable, but it was. Matt, at a systems level, why do we need software to manage our power? Why is it not just power everything up and call it a day? Is it just a limited power budget, or why is it a software problem and not a hardware problem?
All of the energy that hits the spacecraft has to be distributed back into space. Like nothing is for free to maintain the stability of the spacecraft temperature point, right? Which we want to always be between the bounds of what we can operate the spacecraft at. So if you are taking in energy to the solar panels and at 33% efficiency is the most we can get. So let's say that's 350 watts per panel. So that ends up being about 1,000 watts per side. So 2 kilowatts we're taking into the core of the spacecraft. We need to make sure that the core of the spacecraft could distribute 2 kilowatts of power if almost everything is off, because very few of that's going to get, like, let's say we're just in some safe mode, right? We have to be able to, that would be a pretty large radiator size at the temperature that we want to be at ambient on the spacecraft. So if we want to be at 30 degrees C on the spacecraft, that radiator size is pretty massive. So if order to do that without any switching, the cost becomes mass, and we'd have to use a whole bunch of radiator panels there that stabilize it at that point. But then here's the trick. As soon as we do that, now let's say we fire the thruster. We're actually expelling energy out the thruster. The thruster gets extremely hot. Obviously, it's T to the 4 has a different equation. Now we have these giant radiator panels that are actually going to cool the spacecraft too much. And you don't want that heat. So then you would have to also be able to build a spacecraft with configurable radiator panels. So you'd have to do this so that when they pull in a whole bunch, you could have radiator panels. And when they were dispelling heat or not pulling in a whole bunch, you could have a smaller radiator period. Actually, a lot of early spacecraft did this. They were just called slots. And if you look at like Mariner 2 or these, you're going to see this technique done on them, where they will have adjustable radiator panels that they will use, where they will have an actuator that closes or opens slats to give them more surface area. And that allows you to regulate heat on the spacecraft that way. but we're at a pretty big extreme for two reasons. We're really small, so we don't have a lot of thermal mass. So like the delta in temperature change is very quick. So we'd have to have like really high performance, really big slats.
Yeah, that makes sense.
And
that just sounds massy.
And it's just, well, it's a lot of mass. It's a lot of more moving parts on the spacecraft that can break. If they break, you're fucked. There's nothing you can do, right? And so what do we essentially do? We do the same technique, but we have the solar panels there, and we use the solar panels as our slats. So we try to maintain the same amount of thermal dissipation out of the panels that they can withstand, and only bring in the amount of energy needed on the spacecraft to power the spacecraft in whatever state it's in. And that is all done by software.
Makes sense. Nathan, how is what we do with Deep Space 2 and our Deep Space Bus different from power management on, say, a spacecraft that only has to live in low Earth orbit and is always close to the Earth's sun in a predictable way?
Yeah, so I touched on it earlier, but we kind of design our mission profile to be, I think it's 0.9 to 1.2 AU, which means you have different irradiance levels. So we can accommodate that, which means different panel temps, which we can accommodate. And so everything is completely dynamic. The power control for the power generation has no idea where it is. It just knows how much power it needs to generate, and it can find based on the IV curve profile. So it's incredibly flexible.
Nathan, what the you're talking to like 4 people.
Okay, 4 people
on the podcast that have
Yeah.
no idea what the fuck you're talking about. What the hell is an IV curve?
Yeah, so like if you were
Luminance and I got nothing.
See, even Jack doesn't know what the fuck you're
The
talking
first one's
about.
definitely a luminance.
no,
Damn it.
it's current. So
Have you ever heard of the homie Ohms?
Yeah.
Okay, it's his law.
Oh, Ohm's law. Cool.
Yeah. And so you kind of have this nice plot where it defines the behavior of a panel based on irradiance, and then you have different curves based on the panel temperature as well. And so you see kind of like a short circuit current, which is like the most current the panel will ever produce for you is at voltage 0, and you have the maximum amount of current. And so say this is like 7 amps, right? That's not a realistic number, but I'm going to use 7. And then you follow this curve, and it goes all the way down, and it kind of plummets at what they consider the VOC, or the panel open circuit voltage. And that's where you're generating the least amount of power. So you're basically open circuit. If I took a multimeter, what does this measure out at this current irradiance? And so you can modulate where you are on that curve by setting the panel voltage, and we do that with buck converters. And so a non-intuitive way is our bus voltage proportional to our panel voltage is modulated based on this buck converter. So we can set, if we're going to generate 315 watts, we're going to generate 20 watts. And that's basically just moving ourselves on this IV curve that I talked about. So
You're kind of country, Nathan.
Yeah.
You got some camo Crocs on right now?
I do.
Have you ever been to Buc-ee's?
No, I've not. But I hear some people
Have you
call
been
it,
to Buc-ee's, Jack?
Oh, yeah.
I've never been. I kind of want to go. I want to go on a trip and see what it's like.
it'd be sick.
Have you
down?
ever been to, what the hell is that horrible buffet restaurant called?
Hometown buffet?
No, it's like Country Kitchen Buffet. That's what they call it on South Park anyway. What's the, oh God, that's going to drive me crazy. But yeah, have you been to one of those like Country Kitchen Buffet type places with like a gift shop in the restaurant?
No.
No, Cracker Barrel. That's what it is. It's Cracker Barrel. You never been to Cracker Barrel?
Cracker Barrel's not a buffet.
Whatever it is, have you ever been to Cracker Barrel?
I've been to Cracker Barrel one time.
It's a restaurant with a gift shop. That's what Buc-ee's is like. It's a gas station with a gift shop. I
there a
don't
restaurant?
buy into the hype. So
Okay.
I'm not a Buc-ee's guy. I know a lot of people are Buc-ee's people.
Okay, Nathan, let's go to Buc-ee's.
I'm down.
You
Let's
know that
do it.
means you basically
road
have to
trip.
go to Texas, right?
Are they only in Texas?
They're mostly in Texas.
I'll look up one that's not in fucking the great shitty state of Texas.
Texas is great.
Texas is not great. What do you like about Texas? It's flat. It's hot. Trees don't even fucking grow there. The water's brown. There's just no reason that anybody should move to Texas. Period.
Did you intentionally just rage bait, Matt? Okay, I just wanted to make sure.
Let's just continue.
Walking around the factory, there's like a 1 in, I don't know, 3 chance that Nathan successfully rage baits me. Like if I'm just wandering around taking photos, you're remarkably good at it. And I'm only just becoming immune to your powers. Thank God.
I know. I had 2 months of fun, and they're slowly going away.
And now it's all gone, baby. Cool. So you mentioned we sort of plan to be 0.9 to 1.2-ish AU. That's astronomical units.
And don't hold me to that Demian and Loic and James will be mad at me, but that's my rough
No,
recollection.
I'm slacking Demian and Loic and James right now. Like they already know. They're actually watching this live.
It's unfortunate. This is my last day.
But how does our power budget change across the mission? I mean, I imagine obviously as we get further away, we generate less. Does the software like automatically know like where it is and allow us to operate in a lower power state? How autonomous is that?
Yeah, so we kind of Matt talked a lot about thermals, but I think in terms of spacecraft states, which are kind of communication and what the spacecraft is doing. And so if I'm thrusting, that's a lot of power. And if I don't have my panels pointed correctly, what should I do? Do I keep thrusting? Do I stop? And obviously, we don't want to be doing that. So we kind of have this generic catch-all funnel, which is state of charge. So are we in a good state of charge, which is the amount of energy we have stored in our batteries? And if we drop below a threshold, and this is for any spacecraft state, and these are kind of just constructs that we created in-house where we have like cruise mode, we have like a safe mode, and we have a bunch of other stuff. But if I drop below a certain power threshold, I should revert back to what we consider a safe mode, and then eventually min power mode if it progresses that far. And so we handle everything with a kind of a catch-all funnel, and that's kind of the approach that we handle or that we do.
That makes sense. That's pretty cool.
Yeah.
When the Hall effect thrusters are firing for days or weeks at a time, I imagine that's a significant. I mean, that's like the most significant power draw on the spacecraft, right?
Yep.
How does the software manage that versus like, hey, let's need to send, a ping home or what have you? Because the radios, I imagine, are also fairly power hungry.
Oh, very. So we have like 150 watt or so PAs, which are power amplifiers, which are our TX, so back to Earth. While we're thrusting, we'd love to be able to ping home. It's also a question of our position relative to Earth. So is our plume interfering with our S-band? Are we able to even get the antenna pattern pointing towards Earth and stuff like that, which goes beyond us. But we would love to be able to talk while we're powering. And there's also a question of, do I have available power? So when we're thrusting and we have good irradiance, we should be able to do that. But like I said, if we are power negative, so we are generating less power than we are currently consuming, over time, that drops us back into that low SOC state that I talked about, in which case we'd abort the burn and we'd try to reclaim power and go into a power positive state.
That makes sense.
Yeah.
The problem here a little bit is that we're kind of not explaining solar in the right way. If you have a solar panel that is orthogonal to the sun, great. Then you talk about the cosine loss, so it's cosine times the angle of rotation of the solar panel. So if it's sitting right here and the sun's right here, right, and you turn it like this, you can clearly see how you start to lose it. But there's a second angle, which is this direction. And depending on where we're going with the asteroid, this direction is not commandable. This one is. This one is not. So if our beta angle gets too out of alignment with the sun, which is going to be the same cosine loss function, you may not have enough power to use the radio and the thruster at the same time. Now, to be clear, on the spacecraft, especially at beginning of life, that would be quite a large beta angle. So it's probably not a concern, but as we look at extended mission sets, it's something to keep in mind. From the software perspective, though, it's not like the software cares. They know they're getting so much in and they're getting asked to put so much out. And it's really just an algorithmic way of input, output. What's the algorithm you do to make sure that's as efficient as possible? It's really all the software's trying to do. It's pretty simple. I don't know why it's taking these guys so long.
I don't want to care about that either, because if you build in specific states and management, you're asking for errors and it's harder to test and the fault tree becomes ridiculous. So I try to take the funnel approach for air catching and all that. And it's also like, I guess, the beginning of life performance of a panel versus the end of life performance. Obviously, end of life, it's much worse. I really don't take that into account. This is a concept of operations problem, so mission planning and all that would handle that.
And to be clear, we lose about 0.5% on our panels per year, and all our mission durations are less than 2 years. So the way we don't deal with that is we just fucking cheat and say we have short missions.
Makes
If
sense.
we ever go do, like, when we announce the mission to Pluto, we'll have this problem.
Can we do a Pluto mission like as a company fun project in the same way that Rocket Lab's doing a Venus mission as a fun company project, like side time kind of thing?
The difference is that unlike Peter Beck, we would actually do it.
Oh, But you like Cowboy Space, but you're gonna jokingly smack talk Peter Beck.
Peter Beck is already a billionaire and already public. Cowboy Space is a startup that I respect deeply for pivoting to go do a single rocket. And to be clear, I actually love Rocket Lab. We buy a lot of Rocket Lab components, right? Rocket Lab is a great company. I
know you're joking.
I wish that companies really focus on the bottom line as they should. That's what they're getting paid for to do. I wish they would take more risk with that. Sarah Seeger was the one that was going to do that Venus mission with them. I think it's still technically on the docket to go do, but hasn't been prioritized. And I get it. Rocket Lab has a whole bunch of contracts right now. They got to go fulfill.
They got to get Neutron done.
Like we saw their whole earnings standpoint. They got a big rocket to build. They got a whole bunch of contracts. They got enough to do where they don't need to add on a Venus mission. But I wish I still wish Elon would have gone to fucking Mars. Elon absolutely could have gone to Mars at this point multiple times. He hasn't yet.
I don't know that I agree with the last part of that, but yeah, point taken. I mean,
What
Starship.
don't you agree with?
Starship has not been able
Why
to
does
be
it have to be on
refueled.
Starship?
I mean, even Falcon Heavy could only send the car like to a Mars transfer orbit, but not actually Mars. It's like it goes out to the distance of Mars's orbit, but it doesn't actually go to Mars.
Falcon Heavy launched a mission called Psyche,
Right.
which is a multi-ton mission.
Right.
Way farther away than Mars. And actually, in about a week, it's going to do a gravity assist by Mars.
That's true.
To go out to the asteroid. They absolutely could have.
They don't build any deep spacecraft in-house.
No, they don't build anything for Mars.
Oh, so that's your complaint, is that they haven't built that craft.
My complaint is maybe a little bit deeper that I don't think SpaceX wants to go to Mars. I wish they would.
Oh, you think it's a fraud?
I've always thought it was.
Whoa. Play this back at the hearings.
I mean, whatever. He's dealing with Sam Altman right now. I get it. Like, Elon's accomplished a lot. I still wish they would have taken more risk and gone to Mars. And I think they absolutely could have within the confines of that company so far, and they haven't.
What's the point of sending the spacecraft for them to Mars? Isn't their whole point
Who said it has to be I mean, yeah, you can. You know how big the landers were that have gone to Mars?
You mean
less than Psyche?
Like a one-way trip for someone who just kind of lasts there for a week?
Sign me the
or
fuck
just
up.
just like a
I'm
probe
ready.
or something.
Dude, if you told me I could go on a Dragon capsule,
Yes.
there's a 50% chance I'll make it there. But if I make it there, I'll be the first human to step foot on another planet. Load me in that bitch.
And you're going to die in 2 weeks.
Don't even care if I die the next day. They'll name fucking cities after me.
I will say,
planets after me.
at the very least, Matt has been consistent about this basically the entire time.
Yeah, I mean,
I've
it's
known
pure
him.
vanity.
Yeah.
Pure vanity.
That's
Okay,
one
if
way
you
to be in the history
Turn
books.
the vanity knob up to 11. That's what I'm going for right there.
It is interesting that there have been a variety of SpaceX missions that have been announced by them and then never happened. I mean, Der Moon's a whole thing, but there's also Gray Dragon and Red Dragon, both of which were
What the
announced.
fuck was Gray Dragon?
Moon Dragon.
Oh, nobody cares about the moon.
They care a lot now.
Oh, I'm supposed to.
Yeah,
we just
bro,
got
what
like
are you-
$10
what are you
billion to
doing?
fund
What are
for
you
the moon. I'm
doing,
sorry, I
bro?
love the moon. It's a beautiful thing. I
Moon's
think we should
amazing.
do more studying or landing or something.
Moon's great.
Yeah, moon's great.
Big moon fan.
All right, let's move on. Are there phases of the mission where we just cannot run everything we need to, and we're going to have to go by necessity into like a low power state? Like, is there an eclipse when we go behind a moon or something like that? Or are we just kind of relying on distance and beta angle? Also, side note, why isn't it alpha angle? Don't we have a Chad spacecraft? Thank you. Matt doesn't want to laugh. He wants to laugh at it, but he doesn't want to laugh at it.
That was a good one. What was the question again?
I don't know. It was literally just in service of getting the punchline out. Is there a phase of the mission where we are necessarily going to have to go into a min power state?
100%. If our GNC fucks up and we don't point to this or orient the spacecraft in the correct way, that includes the panels as well. And like Matt said, we don't have enough incident rays at the right cosine angle that he's talking about. We become power negative, in which case we drop down to our save mode and min power mode. And these are states that reduce power across the entire spacecraft. So what's essential to keep the spacecraft alive? So comms and a few very critical thermal control loops. And then those step into even reduced power set where we're trying to target the most critical components and their operating ranges. And then it steps into like survival ranges. So if we turn a camera off, like we stop caring about our payload camera at that point because we're in a very bad spot. And so it's what's giving us the most amount of time to debug and recover from that.
What happens if we unexpectedly lose like one of the strings from one of the arrays, or there's some sort of issue? How does the software handle like a degraded power state like that?
Yeah. So we have a
Same kind of deal.
no, well, a little different. Like we can continue to operate. So say we have an instantaneous failure. I'm not sure what caused this, but one of the panels, so it's a trifold, one of those goes down. Our control loop will attempt to compensate for that. So we have a very simple, like it's not a PID loop, it's a P loop. So it's proportional. So eventually the error will kind of catch up and the other two will pick up the slack if they can. If not, the other side picks up the slack. It all depends on the spacecraft state, but this is all transparent to the control loop. It doesn't know if the panel works or not. It will try its best given the current circumstance.
Makes sense. Matt, I know you've talked before about how most spacecraft get killed by software, not hardware. How does that philosophy, if it does, influence the way you want Nathan's team to write power management code?
55% of all spacecraft that have gone outside of Earth's gravity well have failed because of software. It's a really high number, but it's much different than what we're talking about here. I mean, the reasons are a little bit maybe twofold. Number one is when we go into high radiation environments, at least previously, you would always run really, really antiquated processors that are very radiation tolerant. Number two is a lot of the coding standards that NASA has used in the past and Russia has used in the past are always antiquated. So they'll use ones, for instance, Ada was used for a long time. Ada is a safety first language. The problem with Ada is a little bit different, which is all the exceptional programmers coming out of school. You know how many of them studied Ada?
0.
Fucking none.
It's like the same
And
number.
so what you would be able to do is like when you're building a spacecraft from a structural standpoint, you actually can recruit some of the best people in the world on the structure side. On the software side, not so much. Now, actually, Apollo had one of probably the best software teams ever. But when we started going deep space missions, we kind of lost that. And I think for a long time, a lot of the reasons you got this, I'll actually chalk up a little differently, was more incompetence than anything else. You weren't able to hire the best software. You weren't able to use modern tools and modern ideologies to go write code. And you didn't have modern test infrastructures to go test code. It was a very different way to test. The nice thing is we had the 90s and the early 2000s, right? We had kind of this internet revolution that really, and if we look back on that, what did it do? It actually lets you have a whole bunch of small companies that tried different theses for how to write software. And all the shitty ideas failed and went bankrupt, and all the good ones came to fruition. And that's where you get like the agile development methodologies. You get all these different methodologies of how to go do, but more importantly, you get some very basic tools that help you complete this. There's this little known guy named Linus Torvalds. You guys may have heard of him.
Didn't he make some operating system that like nobody uses?
I'm not sure if that was true or not. I don't remember.
Slander.
But what he did make was Git. And like one of the best tools we have is Git. Before this, it was like people would use a tool called CSV, CVS, CSV, whatever the fuck it was called, right? And like all these other copy and save, like whatever. There wasn't a way to manage software across teams. That essentially was solved for us with Git in a whole bunch of great ways. The way we do unit testing, the way we do continuous integration and building, the build pipelines, like we're not reinventing the wheel there. We're just implementing kind of open source projects that have done this. Like that infrastructure has been built up so well that we can have a small software team. The language choice we chose was Rust, which is, I think, extremely helpful and one of the best decisions I've ever made as a CEO.
Shut up.
That was my next question is for Nathan, like what are we writing all this in? It's Rust?
Yeah, it's Rust. And
Who picked that?
honestly, that predates me, to be honest.
That's right.
Must have been Matt.
Must have been when there was like one guy at the company.
Must have been like Matt,
Oh,
yeah.
shit.
Is that like legitimately, I don't know anything about programming languages. Is Rust, are you happy with that choice?
The learning curve on Rust is tough, but it
That
is.
wasn't the question. Are you fucking happy?
I was getting to it. It was kind of like a long, meandering
want your long
answer
winded,
where I
just
would
say
come
it.
back, I tell you my life story and my motivations, and then we get to the answer, which is yes, I'm very happy with it.
Nice.
But it's a language that provides us a lot of safeties when you write the language. So the inherent design of it and the syntax provides safeties that other things like at C, you would have to have a static analyzer that would provide those safeties. And it's built into the language itself. And my kind of idea is you're only as weak as you're only as strong as your weakest programmer. And so this kind of takes a lot of the basic fallacies out of programming. It doesn't remove all of them. You still need good people, but it kind of helps remove that baseline and says, I'm going to have, like, we don't have memory issues on our application programs. We have logic issues sometimes, which we catch with CI, CD testing, integration tests, and all that. But rarely are we ever debugging memory leaks. Pretty much never.
And if you write in C++, holy fucking Jesus. Like, the problem is that some of these languages have gotten so bloated to it. C++ is the antithesis of this to me. Like, there's 40 different standards at this point. I don't even know what you have to ask, like, cool, you're writing C++, what version? What are you using? Like, how many keywords are in that version? How do they even work? They started overwriting keywords. Like, holy fuck. Templates, like, people, object-oriented programming as a whole, I can go on forever about this, I think is a total fallacy and one of the worst things that's ever happened to software. And I think Rust gets down to the nuts and bolts of what software is. It is a way to command hardware. Let's leave it at that.
Can we migrate all our code to Swift?
We could, but I might quit.
All right, we won't do that. We won't.
I'm not actually sure we could. I don't think there's a Swift runtime for processors, for our microcontrollers.
Nothing's stopping us from making it work. It's all just ones and zeros. At some point, we can make it work.
Listen to that can-do
Technically,
attitude.
like, okay, in the absolute sense, yes, but Swift is closed source by Apple, so I don't know if that's true. I don't know if we could actually
What's
do it.
that technique where you give like a really, really exact product definition, you give it to an AI, and then it creates like the equivalent, and then gets around the loopholes?
I'm going to do this after this call. I'm going to go see if Claude can install Swift on our processor, and if we can, we'll rewrite the power in Swift.
Okay.
We're actually going to make it all emojis.
What have I done?
Everything makes it to machine code at some point, so we could make it work. So
What processor do we use?
We use Dose.
What is that?
we use two types.
Or that's what I meant, yeah.
So we have a Jetson AGX Xavier Industrial, which NVIDIA has now made end of life July 2027.
Yeah, thanks, Jensen. It's supposed to be fucking 2031.
It was for many years. If you go on the Wayback Time Machine for the life cycle for the product, it just changed on March 7th. So that was great. But
they can discuss that on their little airplane trip.
Ridiculous. And then we use what's called a SAM RH71, which is a Cortex M7 provided by Microchip. So it's a Cortex M7, which is an architecture that is purchased from ARM, and then Microchip implements that specific architecture into their own processor that is rad hard, and they integrate a bunch of cool peripherals into this microprocessor. So part of the reason we chose it, not only is it rad hard, but it has SpaceWire, and our radio is SpaceWire only. So those are kind of the two driving factors there.
Sorry, what the heck is SpaceWire?
It's our comms link. It's I'm going to get detailed, but it's LVDS physical layer with a...
What is LVDS?
He just said he was going to get detailed.
Low voltage differential signaling.
Thank you. Please, talk like
It's
a
like-
human. Nobody
it's-
talks like that.
Kind of similar if you want to think about RS like 422, 45, stuff like that, where it's differential, so you get a lot of noise immunity. And it also does some fancy stuff with the clocks. And then it has a kind of a specified transport layer on top of that, which frames the data and tells you how you can interact between nodes. And it has cool things like there's SpaceWire routers and stuff like that. It is more of a big aerospace kind of concept, but we're kind of pushed into it because we wanted to use this specific radio. So,
Matt, do you have like a personal, I guess favorite would be the wrong word.
Vendetta?
Well, he's got plenty of those. I hope Rachel switched to your camera in time for that. Jesus, what was I even? Oh yeah, do you have a personal? You said 55% of the spacecraft that have gone beyond Earth's gravity well have died due to a software issue. Is there one that like particularly sticks in your craw? I'm kind of thinking like Mars Climate Observatory, where they. What was that? The metric to imperial conversion?
What was the IM2 one that was on that ride share?
Oh yeah, that's the Lunar Trailblazer that
Trailblazer.
It had the incorrect solar panel pointing. Like,
Yeah.
is there one that like really like it's like a splinter in your skin or a piece of corn in your teeth?
No, I don't. I mean, like, look, it doesn't bother me that spacecraft fail. I think it sucks for the scientists on those missions, and it's a bummer. And I want to see more space exploration. But like, it's not gonna piss me off that they failed. It's a learning experience from that standpoint. There's a lot of lessons to be learned from how spacecraft are developed and how technology is developed and how it's done. And I think missions like the Cassini mission, which had a ton of failures on the way to Saturn, and there's a lot of stories here about how Cassini was done and rewritten. What you can really learn from Cassini was that how it was tested. Cassini was not tested correctly from a software standpoint. And that's looking back on it to something they did in the mid 90s to now, it's pretty evident of what went wrong there, right? And we can go fix that. So it's not necessarily about learning about spacecraft and saying like, oh, you failed, you suck. It's saying you failed, why? And is that a problem? Most of this we do by, honest truth is, this isn't a secret. It's not actually that hard to figure out. You just got to test your shit. And I think that's why at this company we have this kind of mantra of like, what is the smallest time to testing that we can do? And if we can solve that, not just on hardware, but on software, you get rid of a lot of the problems. And if there's any more problems, we'll just kill everyone on the team.
That's certainly an incentive to do good. All right. Let's talk about testing. Speaking of, good segue, Matt. How or what does our testing pipeline look like? Like unit tests, Matt mentioned, integration tests, hardware in the loop, and we've got Hiddle right over there, like 20 feet away. What does our testing profile or pipeline look like?
Sure. So we develop kind of a tremendous amount of software. And our first layer is obviously the unit test. So does this function produce, if it's A plus B, does it produce C as expected? And that runs every time on what we call our CI pipeline. So CI stands for continuous integration.
Is that like the Jackson 5 song?
What the heck?
A, B, C. It's as easy as 1, 2.
I'm so glad neither of us talked over that so we can clip that audio to blackmail Matt with later.
Well, there's not a blackmail. Jackson 5 was amazing.
No, but like
So is karaoke.
But we have audio of you singing.
Please put some music.
I don't think
behind
I've
it.
ever heard Matt sing in my entire life.
You just did?
Really?
Yeah.
I sing all the time.
I think I've known you almost 3 years now, and I've never seen you sing or heard you
Just
sing. Sorry.
because you're not cool enough.
Fair enough.
Company karaoke outing. I'm demanding it now.
Could be a dangerous event.
What do you sing at karaoke?
What do I sing?
Yeah.
I've never done karaoke.
Really?
Not once.
Oh, we're for sure going now.
Why
Yeah,
would
let's
I?
go.
Why would I ever do karaoke? Nobody wants that.
You sound like a man who needs karaoke.
You
now.
needed to sing Gundam style.
Gundam style? That's a totally different song.
Clip
than
that
what-
too.
Yeah.
Yeah, like
Is that like the Weird Al remix of Gundam
Yeah, that's the
style?
Weird Al with
Yeah.
the actual Gundam robots,
Yeah,
right?
yeah. Got it. I'll think about it. Testing. Let's
testing.
talk about
So
testing.
it's unit tests, kind of lowest level. Does function do what function says it does? And then there's integration tests on top of that. And I was talking about the CI pipeline. This is kind of, we basically run a cloud compute cluster where you put a PR up, which is a pull request saying, I'd like to merge my code into what we call our main branch. And main branch will always be the source of a release branch. And so this could be like our flight release, release for some testing or anything like that. But you were asking for your team to look at your code and such that it makes it into this branch. And it goes to the PR process, which is the reviewers. You need 2 flight software approvers to kind of look at your code and say, hey, this makes sense. We've talked it over, we've sat down, or I've looked through it myself, and this meets the standards.
Who's the hardcore code reviewer?
Who is the most
Karen?
hardcore? I think Armand at times, and
Hell
then
yeah.
and if you push Kieran and you kind of like catch him on a bad day, he will do the most rigorous review, which I appreciate. But I think he thinks it's trying to get back at you, but it's the most helpful thing he can do.
So he's just like rage reviewing.
Yes, and it's
Oh, amazing.
phenomenal, and it's
Amazing.
great. And so sometimes it's the most
Pissed off.
helpful. Yeah, it's amazing.
Sometimes you just gotta let the anger consume you.
Oh yeah, but yeah, no, having reviewers is great.
I love how you just agreed to it blindly. Like, yeah, sure, consume you. Yeah. Anyway,
you.
testing.
Yeah. And then from the PR itself, the code goes through a bunch of automated testing. So as we add new functionality, you have to provide associated unit tests and then eventually hardware tests as well. So we have hardware in the loop tests, which is the spacecraft laid flat on a table, and the pipeline runs automated testing against that as well. So if I make a change, does the existing functionality break? And that's called regression testing. And does my new functionality that I claim work, does that actually work? And so you're basically proving this. And then once you have that proof, it stays in there for the life of the project. And so you get more test coverage and better regression testing. And that kind of continues on. And that's kind of our approach.
Could we just replace you guys with Claude?
I've tried and I was disappointed. But
What about Mythos? Our spacecraft can be up there just like one-shotting, zero-daying other spacecraft like it's nobody's business.
I think AI can be a helpful tool. If you are a bad programmer, AI amplifies that And if you're a good programmer or a good software engineer or just a good engineer in general, it amplifies that. But it can also lead to kind of a cognitive decline that I've noticed. If you become too reliant on it, you lose the ability to on it. Because this kind of goes back to why missions fail. As we've kind of progressed from like the Apollo to now, we've built layers of abstraction. We have operating systems. Who knows the stack all the way down to like the lowest level? You can't. There's 30, 40 million lines of code. You can't do that. And so this is kind of
That is a lie. You can. There's a new company that's trying to do that.
Let's do what?
Remove all of the layers of software between the assembly code generation and your application. And
Where's
if
it
they
gonna
could pull
run?
it off, the efficiency gains you get are huge.
Where does this code run?
It's essentially like, could you write every application you do on bare metal? You can. It's just the
Yeah.
reason we don't is because we're trying to add all these tools in
Yeah.
to make it easier to do. But if you could do that, how much time could you save and do things like,
Are they making another language?
yeah, it's fucking sick.
Well,
I'll talk to you about it offline, but it's pretty sick.
Okay, I'll take that as an action item for myself to ask you about why that's sick and not stupid. It sounds like
Yeah.
another language.
Well,
It just sounds like coding with extra steps.
I mean,
They had a good sizzle reel. That's what got them.
yeah, they had a good sizzle reel. It was pretty sick. They had a sick logo.
They
too.
pivoted real hard.
And they
Real
moved,
It's a
good pivot.
Yeah.
They're
and they moved to
real
Florida.
real underdogs. They just you didn't expect this out of them.
I was like, you know what, I'm in.
Oh man, Matt, we've talked a lot about risk.
Are we done with this podcast?
We
Where's
got-
the
this is-
question?
this
Where's
is
the fucking
literally-
mailbag?
This is literally the final question.
Do we have any mailbag questions?
We have no mailbag.
Nobody emailed us.
We did all our mailbag in the last episode.
When was the last episode?
We can make up questions for each other, and I have some good
We
ones.
could do that. I mean, I will answer any question you ask me.
Rachel
You
has
promise?
never asked a question on this show. Oh,
Yeah.
wait. Hey, hold on. Nathan's got some dirty questions. Let's see what we've got. Go ahead.
Wait, I have one more question in the show
Okay,
prompter.
okay.
Let's get through this
Alright.
quickly so we can ask
Matt,
you.
we've talked a lot about risk on this podcast and in general, and accepting a slightly larger amount of risk because if we don't, we're not ever going to fly, and things become $1 billion NASA 10-year, etc. Get me? How do
Got you.
How do you think about the acceptable risk level for flight software specifically? This isn't like a piece
That
of
That
hardware
was the
that you,
laziest question you've ever asked, first off. Second off, I
That's a
would
good
say
question,
that
Jack.
I
I
thought it
think
was a
that
good
our flight
question.
software is held to a higher standard and less risk than I expect to have on a NASA spacecraft. And the reason is because there's no reason for us to make a concession. We have the tools, we have the ability, we can test it quickly. There's no reason we should not be holding ourselves to an extremely high standard and carrying less risk there. We have to carry more risk on other areas of the spacecraft. Software is not one of them.
what a good answer. All right, let's do mailbag. Ad hoc mailbag. Nathan.
Jack, what spawned the bad mood today?
Hey, Jack, what happened in your life that went so wrong?
Yeah.
I was
Seems
born.
Like you're,
Are you okay?
I was born.
Seems like you need to have a little discussion.
Shouldn't have been born. Should have just not existed.
What are we gonna do when we run out of?
Of Jack's?
No. What's that stupid drink you have right there?
Rock stars?
Yeah, the orange rock stars.
They don't make those
What's
anymore,
your
right?
next drink?
No, first off, there was this rumor that they were being discontinued. That's not true.
It's not true.
There was a supply and demand issue, primarily because I think we are all the demand. And they just had a little lapse in supply. We're fine. Rockstar is still producing this drink of choice. This is
There's a long silence.
the
there.
lifeblood of the company.
Can
You know
like,
how
hold
much
it like
more
a-
productivity we've had due to this drink than anything else? Like, Kieran drinks this. Armand drinks this. Armand
Armand?
is straight addicted.
Armand drinking that was scary.
Addicted to
Why
these.
was it scary?
Kyle drinks like 10 of these a day.
Kyle does drink like 10 of those a day.
Armand, if you get him to laugh, that is a good day. And so Armand doesn't change his routine ever. He shows up at 8, he leaves at 5:30. And that man is like a machine and clockwork. And to deviate from any pattern, which includes substituting coffee for a rock star, was absurd.
Noted.
But he did it because he recognized the greatness of what is the Rockstar Recovery orange flavor.
Dude, we went to Meteor Crater, and this guy, I'm like waking up, I'm like trying to come to terms with the fact that I'm at 7,000 feet and I'm about to go on this crazy desert hike.
Were you sick?
No, but the altitude definitely had an effect
He
on
was,
me.
he was
Altitude
cardio
sickness?
sick. No, he's cardio sick.
Cardio
'Cause,
sick.
When we landed on the airplane, I made him go run with me.
Yeah, it was horrible.
It was amazing.
It was horrible. It was horrible. But yeah, he gave me one of those things, and I'm no stranger to energy drinks. I'm drinking a Red Bull right here. He gave me one of those. Dude, I felt like my blood became bees. Like it was like, why am I vibrating? I don't know.
Yeah, and then we went and went into a giant hole in the ground,
And then we went and crushed Meteor Crater.
crushed it, bro.
Our best company investment, though, has been the Breville espresso maker.
I love that thing.
I don't like coffee.
I can
And
tell.
I want to put a camera above it to see how much time we're wasting making fucking coffee. I don't know if it's worth. I don't know if the juice is worth the
You
squeeze.
know a guy that has cameras. Do you want me to actually do that? I feel like it'd be a good time
Yes.
lapse, honestly.
That would be a cool time lapse.
I feel like it would be a cool time
And
lapse.
then we could use AI to determine like who's standing there the most, and just start producing that on the Slack channels.
We can get a Grafana dashboard too. Number of
Grafana
cups.
dashboard, host
Yep.
it up, and be like, Robin, you spent 37 hours last week at the coffee machine. What happened?
We could have like when we do our all hands and do our raffles, like the person that takes the least amount of time at the coffee machine could get like a hand in the raffle. All right.
Hold on. Doesn't Rachel get to ask a question? Rachel's never asked a question.
I'm pretty sure she has. Go ahead, Rach.
I didn't listen to that episode.
Also, you're not going to come through on the mics, so we're going to restate the question in the answer.
You're stressing her out too right now.
What's your goddamn question, Rachel?
Okay. If you were to lead a pivot for AstroForge,
Oh.
what is a pivot that you would find feasible and stimulating?
So the question was, if we were to pivot as a company, what would we find stimulating and feasible?
That's funny. What was AstroForge before?
Dude, we've already pivoted once.
Exactly.
But if we had to repivot again, I've thought a lot about this.
Here we go.
Deep space data centers in space. Think about it. One of the biggest problems is cooling. And we say that space is cold. But you know what's colder? Deep space. So what if we took data centers and moved them to Pluto?
Comms.
Oh, I'm
latency.
sorry. We're using logic. Put it at fucking Pluto and it will be super cold. Think about that. Like, there's no thermal problem at Pluto. Pluto's an icy world.
I cannot wait for the AI bubble to just burst. And I can stop hearing about data centers in space.
Yeah, but have you heard about data centers on Pluto?
Can we end this?
All right. Thank you all for watching. Thank you so much. If you have any questions for Mailbag, so we don't have to ask each other ridiculous questions like you just saw, you can email them, tweet them, leave them in the comments. You know how the internet works. Thank you, Nathan, for being on. Thank you,
Jack.
Matt, for being on. We will see you all on the next one.